Thank you.
Mr. Townsend,
Yes.
could I leave 10 minutes early from class for the pep rally? I'm one of the escorts, so I gotta go get dressed.
Yes, but whoever asked you to do it will need to mark it in gradebook. Who asked you to do it?
Oh, Elizabeth Thomas.
Okay, she'll need to change it to school business.
Interesting.
I can only put in that you left. I can't
Yeah.
change the type of absence that it is.
Got it. I'll just turn this in right here. It's not loaded.
Yes, sir.
All right, good morning, guys. Before the minute of silence kicks on here, you might want to double check that you got number 91 turned in from yesterday.
You could usually have an extra day between, but you didn't this time, so.
Good morning, FHS. It's finally Friday, February 9th, 2024. Would you please join me in a minute of silence? stand if you are able and join me in the pledge? I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Participate in the Colors Day dance. Please remember that you must
My
pay
time is
all
in
fines.
here because
Yes.
it's not loading.
Yep.
Thank
Please see
you.
Rebecca Lawson in the Arena Building or Shannon Trout, Phase 4, 3rd floor. Thank you and have a great day.
Okay, if you guys were trying to turn that in the Google Classroom and having trouble, I think our Wi-Fi has not been working the best, so you're welcome to come give me your hard copy here with your name on it if it didn't go through.
But please do that now if that's the case.
Okay, so today we are going to do a little bit more, we're going to start class with a little bit more of the test review together. Then we're going to practice some more integration, some use substitution, some not. Turn in one assignment from last class, the notes, to give you some points for participating, and then finish off class and homework, having you work through the rest of the review so that you can start to identify what it is that needs some more attention. So, I need you to get out number 88 in your binder. That was the Chapter 5 test review. It has the 3 FRQs on the front. And we've already looked at the first 2 together. Now again, I do think it's valuable to maybe look at it a second time as part of your studying, especially the parts that you circled as not being intuitive to you. Well, you can get the most out of all that. But this third FRQ is another very common type of FRQ for the AP exam, so good chance we would probably use it sometime this semester too. But it's not one that we have practiced yet, so this will be your first exposure on how to approach some of this. Alright, so they give us a figure, and if we read the directions here, this over there represents function f. This is f. And then they define some function g. G has something to do with f, and because it's integration, it's probably going to have a lot to do with area under that curve, area under the function to the x-axis, like we've been doing. But before we even dive into this, what I really need you guys to know as a strategy here for this question type that I think just makes this like 10 times easier is if out to the side, and I don't know where I'm going to do it. I'm going to try to squeeze it in here. If you write this statement down, G is integrating one. Didn't know I could even do that. Okay, G is integrating 1 to x of f. At some point, and actually very soon, we're going to be asked questions about G prime, G double prime, and we don't have to want to mentally think about this every single time. So, again, you're going to get sick even on this one FRQ of how many times I point out how helpful this is. But let's just go ahead and take the derivative of both sides. The derivative of G would be G prime. And what would be the derivative of this stuff? Not f of t, f of x. That's the second fundamental theorem, so you do need to know that so that you can be able to do that. And then when we need second derivative, just take the derivative of both sides again. G double prime is the same thing as f prime. So now when they ask me questions about G prime, I know it's the same thing as f, which is right here in the graph. If they're asking something about G double prime, it's the same as f prime, which is like the slope of f. Remember, derivative means slope. If they're asking me something about G, it's like the area under the curve of f. So now I have a reference to where all of these pieces should come from. So when this says part A, calculate G of 4 So if I plug in 4 for x here, I'd have to plug in 4 for x here. So this is really just asking how much area is there from 1 to 4. So we need to go over here and we need to calculate how much area between the x-axis and the function there is from 1 to 4. So you could do like a trapezoid here. Personally, I'd probably just do a square and a triangle. That down there is -1/2. This up here is +1/2. Those are triangles. I think we need these values later, so I think you should probably try to like write in the area of each one so you don't have to redo that again later. And then this one is, let's see, 1/2. If I go from here, height times base. So this is 3/2. So it looks like the area under the curve from 1 to 4 would be 1, 1.5, 1/2. So that would get me up to 3, but then subtract 1/2 because this much was under the x-axis. So back to 2.5, 5/2. So I feel like you should be able to do that part because I've said a million times at this point, integration is basically the same as area under the curve. So especially if you don't have a function that you can do the antiderivative of, they're expecting you to chip away at this and break it up into geometric pieces that you could do. Okay, but for the next part, g prime of 4, you start thinking about, that's a lot to do in your head. And we're going to be asked similar type of questions throughout this. So if I want to know g prime of 4, that's where I think this is helpful. G prime of 4 is really just the same thing as f of 4, which would be a point on f. So on f, when x is 4, y is -1. The answer is just sitting right there. And that's so much easier when I can just see where I'm supposed to, what part of the graph I'm supposed to extract that from. And then finally, g double prime of 4. G double prime of 4 would be the same thing as f prime of 4, which is like the slope of f at 4. So at that instant, it's got to be linear, so we can just count rise over run. And it looks like at that instant, the slope is -1. So again, g of 4, I plugged in 4 into g, and it was basically telling me take the area from 1 to 4. Add up the triangles and squares and all that kind of stuff. G prime of 4, because I wrote that reference box out to the side, I knew it's the same thing as f of 4. That just means a point on f. When x is 4, y was -1. And g double prime of 4, my reference box said that was the same thing as f prime of 4, which is like the slope of f at 4. So I counted rise over run on f at x equals 4. So none of those are too terribly difficult to find, but again, the mental stress you're going to put on yourself trying to figure out, if I plug in 4 here and 4 here and then take the, well, you got to take the derivative first, you don't want to have to keep recreating that wheel. So again, all I did to come up with this that made this a little bit easier is I wrote down what they had, took the derivative, took the derivative. Took the derivative second time, took the derivative second time. And now, no matter what they were asking, I knew where on the graph it was going to come from. Okay, and actually, you know what, just so I do less back and forth, I'm going to go over here now. Is there any, are you guys okay with part A, where those parts came from? Anything you want clarified? I'm not going to focus on the point parts too much here, but on this one, this FRQ, I think A through D were an actual real released FRQ. I don't know what year it came out, and I think E and F were added on by some other teacher. But when this was a real FRQ, you got 1 point if you got G of 4 correct, and 1 point if you got the other two parts of part A correct. So 2 points there with very little work. You just have to know this relationship. Okay, B wants to know what's the instantaneous rate of G, so that would be G prime, at x equals 1. Well, here's another time where this is a shortcut, where I've already thought of that, I don't have to think of it again. G prime of 1 is the same thing as f of 1. Good to just go ahead and write that down, because sometimes you can get a point there for saying that as justification. So, when you look at your graph, what is f of 1 equal to? 4. Good. Just a point on f when x is 1, y is 4. The answer is just sitting right there, but we have to know how g and f are related. Bless you. So, B is probably the easiest part, especially if you have this written down. Alright, C. Find the absolute min of the graph on G from -2 to 4. So we want to minimize G. So to me, if I'm finding absolute max or absolute min, the back of my head, I know that's extreme value theorem. You don't have to say you're using extreme value theorem, but it helps to identify that, because extreme value theorem tells you you better test the endpoints, -2 and 4, and you better test any critical numbers. So that would be like where it's crossing the x-axis, because it's probably being maximized or minimized at that point, which would be 3. Those are the points that we need to test. So one of these we already have from part A. We already know G of 4. What was G of 4 equal to? Okay, so if we're paying attention, we don't have to redo that one. For 3, if we look at the function of G, and I'll write it back down over here, it's basically just saying the area from 1 to whatever you want x to be. So if you want x to be 3, we want the area from 1 to 3. Well, if you wrote these little area values on your graph, you're just adding up again. So this would be 2, 3. The area from 1 to 3 is 3. Okay, and then the area from 1 to, I'm going to write this one out because I think this one's a little trickier. The area from 1 to -2. Now, so I need to find this last little area piece here. So let's just go ahead and do that. This big triangle, 1/2 base times height would be 6. It's above the x-axis, so 6. But if you want to know the area from 1 to -2, again, be careful. That's very different than -2 to 1. So you have some options. You can count up that area and then make it all negative because you're going right to left instead of left to right. Or what's probably the safer bet is just rewrite this question, change the bounds, switch the bounds, and remember to switch those bounds to make it mathematically legal, you need to multiply it by a negative. So now I can say it's going to be negative the area from -2 to 1, which would be 6. Oh, that's it. So -6. Again, the area is not 6 though, because going 1 to -2, you're going right to left instead of our traditional left to right, which makes it opposite. Okay, so back to part C. What's the absolute min? And justify your answer. Well, now it's pretty clear the min was at, the min is -6. Okay, and for this question, they gave 1 point for the answer. They gave 1 point for the endpoint analysis, which would be showing that you tested these two, and 1 point for the interior analysis, which would have been showing this one. So again, last semester, this extreme value theorem, I always call this a candidate's test. You don't need to know its name, but a candidate's test is the safest way to justify your answer. You don't need to also include a sentence or two explaining. This is enough justification, and occasionally you get a bunch of points for this. So if you don't know to test the endpoints, you lost a point and you wouldn't have got the final answer, so you lose 2 of the 3 points if you don't know to test the endpoints. And if you didn't consider testing the critical number where it was crossing the x-axis, you lost a point too. So even if you could look at that and see at 3, it can't have the minimum area because there's all that area being added before it. This is still the safest way to show that. Show the endpoints, show the critical numbers, and that's going to cover you as far as getting the answer right and your justification. Okay, on to part D. Let's see if I can squeeze in some space here. Trying to make it where I can still see my graph. Okay, part D. At x equals 1 and x equals 2, the values of these x coordinates, or I'm sorry, the second derivative is not defined. Now, really, we should know that anyway, because right here, there's a cusp, so I can't take the derivative, and right at 2, there's a cusp. Even though it's not nearly as sharp as a turn, the slope can't go from this to this at an instant. It's got to be curved over time. So they're coming out and saying the second derivative does not exist there, but they would like to know which of these, if either, are points of inflection. So you have to remember, points of inflection is where the concavity is changing. So we need the second derivative. We need the second derivative to go from negative to positive to be an inflection point, or positive to negative to be an inflection point. Well, the good thing is, this little reference here reminds us on how to figure out stuff about the second derivative of g. Second derivative of g is the same as the first derivative of f, which is like the slope of the graph of f. I've got the graph of f, so I can just think of slope. So here's one place where it might be changing concavity, and here's the other place it might be changing concavity. Since the slope here is positive, since f prime is positive, that means the second derivative is positive, because those are the same thing over in our little box here. And then the slope switches to negative. So if at x equals 1, if f prime is going from positive to negative, that means g is going from positive, or g double prime is going from positive to negative. So that would be yes, that is an inflection point. So x equals 1 is an inflection point. Again, I understand this relationship. If you're not understanding how I know these two are tied so closely together so quickly, again, I'm just thinking of this over here. G double prime is the same thing as f prime. Okay, if we do the same thing for x equals 2, x equals 2, f prime is negative before that, which means g double prime is negative. And then after that, it stays negative. The slope of f stays negative, which means g double prime stays negative. And if the concavity is not changing, then this is not an inflection point. So again, I don't know when they asked this FRQ, but they gave 1 point if you figured out x equals 1 is the only inflection point. They gave 1 point if you showed why it's an inflection point. So you're justifying. And 1 point of showing why x equals 2 was not an inflection point. So again, the old stuff you have to remember there is inflection point, concavity has to be changing. And the new part today, to know what the concavity is, you should be thinking about the slope of the graph. G double prime is the same thing as the slope of f. And without making that reference, that is very difficult to do. It's not like I'm extracting really hard information, but conceptually, seeing how these pieces fit together takes quite a bit of practice. Okay, so since I think A through D are the real questions that were really asked at one point, not that there's anything wrong with E or F, we're going to go ahead and talk about those too, because that's a good review for you as well. But I'd like to pause here for a second. Is there any parts of A through D you'd like me to verbalize again before we keep going? Okay. I'm going to erase this to get some space here. So again, I think some teacher, I don't know if it was not me, but maybe Miss Cross or our other calculus teacher, it could have been somebody else if we borrowed this off the internet, but they asked, what if you wanted to know stuff like, for G, when is he increasing, decreasing, concave up, and concave down. So just because I don't think these are part of the real FRQ, you guys know these often show up. So again, think about what G is. G is really the area under the curve from 1 to x. So if I want to know when this is increasing, well, it looks like if you started off at -2, we increase in area because there's area above the x-axis until you get to x equals 3. From -2 to 3, G is increasing because the area between F and the x-axis, which is how G is defined, is increasing. Then it's decreasing when the area is getting lower, and that would be down here from 3 to 4. That's decreasing the area under the curve, which is what G is, because it's negative, it's below the x-axis. To know when it's concave up, I would want to know when G double prime is positive. Once again, I think this little reference is helpful. If I want to know when this is positive, it's the same as knowing when this is positive. This is the graph of F, so F prime would be his slope. So when the slope of the graph is positive, this is positive and it's concave up. And the slope of the graph is positive from -2 to 1. And that's it. Same reasoning for concave down. That would be when G double prime is negative, which means when F prime is negative, which is the slope of F, which would be 1 to 4. Again, significantly easier if you have this to keep referring to. And all I did was write down the initial statement, derivative of both sides, and derivative of both sides. Okay, and then to finish up, F, write an equation of the tangent line to the graph of G at x equals 2. Well, just like last semester, and again, hopefully we'll get a few weeks of AP review, but tangent line is always a linear line, so you should start off with point slope. They're telling you which x value to use, x equals 2. To know the y value, I could plug 2 into G and solve for y. So if I plug 2 in for x and G, 2 for G would represent the area from 1 to 2, which I have this from earlier. That is 2.5. When x is 2, y is 2.5. And then finally, the last thing I need is the slope at x equals 2. Or the derivative, same thing. The derivative of G is the same thing as f of 2. And what is f of 2? 1. It's just referring to the point there. G G prime of 2 is the same thing as f of 2, and when f is 2, y is 1. That would be the tangent line. So, similar to what we did last semester, but extracting the m and the y is a little bit different. M still represented slope, but for you to know the slope of G, you had to know this. Slope of G was the same thing as f. Pull the number off the graph. And for y, when x is 2, to solve for y, you had to plug in 2 for x and solve for y and G. So it ended up coming from the area from 1 to 2. Now, so I don't know. Some of these are a little bit tough. I do think it's probably worthwhile to maybe look back at a few of these, especially at the start. I think it would be a disservice to yourself not to force yourself to try to make this again, because this FRQ is pretty hard to survive without that. Is there... Oh, I was also going to say, to me it's very conceptual, which is kind of nice. Like, yeah, this was a long FRQ, longer than a real FRQ, but I didn't really have to do too much work. There's not a lot of steps to any of this stuff. But if you don't know how things are connected, then it's hard to move forward. So I think some of you like more of the process type questions, and some of you like more of these conceptual type questions. But your AP exam definitely has been moving more towards conceptual. So, and less long questions that have 5 or 6 steps. Okay, so what about year F? Is there any part of that you'd like me to verbalize again before we move along? Now, again, I don't know if this will be the FRQ when we get to your next test. I do know that you should try it again. I do know that in your AP review, we will practice 4 or 5 more of this type of FRQ before your AP exam, because they often like to ask these question types. So I know it will get easier for you, but you need to put in your best effort in case it shows up on your next test. Okay, next up, the biggest chunk of our time here, class time, is going to be towards some integration practice. So I gave you U-Sub worksheet 1, and even though it's called U-Substitution worksheet, not every question needs to have U-Substitution. In fact, my 8A class, that seemed to be what they struggled with the first 10 or 15 minutes. They were trying to do U-Substitution on almost every single question. But if you look at question 1, you don't need to do U-Substitution. You can just undo the power rule 3 times. Some questions like number 5, you could FOIL those together, and then you probably don't need U-Substitution. Just because you have learned U-Substitution doesn't mean that every integration you ever do now is U-Substitution. So with this one today, I'd like this to be a little more structured than normal, just because you guys are probably going to have similar questions, and so if I help 10 people individually, then that's not going to help me. That's not going to let me help you guys a lot with a lot of these questions. So I'm going to ask that you work them in order, please. Please try question 1 before you try question 2. Try question 2 before you try question 3. That way we've all kind of eyeballed the same questions. And I'm going to give you about 5 or 10 minutes, and then I will ask for questions for maybe like 1 through 4 or something. So hopefully you will have tried those, and if you need me to go over those, then I can. So go ahead and dive into that, please. You will need more space than this worksheet gives. Not for every question. Question 1, I think there's plenty of space. So you're welcome to use a separate sheet of paper, or if you want to just copy the question to the back page, the back is blank too. So feel free to use the back as scratch paper. You probably will have plenty of space if you do it that way. Okay, so again, I'm going to put in these homework grades, and then somewhere between 5 and 10 minutes from now, I will offer to work any of the first couple that you may have had struggles with. And of course, I'm giving this practice because I think the majority of us still need more practice with integrating and use substitution. I do realize some of you are probably actually pretty good at it at this point, but if that is you, this can still be an opportunity to practice your speed and being able to go through the questions a little bit quicker. Kind of just like the ACT, the more questions that you feel really good at and can answer correctly but also quickly on your AP exam, that's going to buy you more time to think about and retry and check on things that you don't feel as comfortable with. So and I think I've said this, but your AP exam heavily tests use substitution. Typically, there's always one FRQ where you have to do use substitution to do it by hand. And typically, there's 2 or 3 or 4 or 5 multiple choice questions that are use substitution. So after about 9 minutes there, let's say questions 1, 2, 3, 4, or 5. Any of those that I could help by going over. 1, 2, 3, or 5. Yes, Julie. Number 3? Sure. So 3 just says this. So since nothing's written here, mathematically that's going to be an understood 1. And then so the antiderivative of 1, well, not x because this says dy, so 1y. The derivative of y would be 1 if you're taking it with respect to y, and then plus c. So looks a little bit different, but should be a lot less work than some of them. Okay, anybody else? 1 or 2 more from 1 through 5? Okay. Then I will restart the timer, and then in another 5 or 10 minutes, I will ask for probably questions 1 through 8 or 9, somewhere around there. Another opportunity here. Let's say anything 1 through 9 that I could help with. Yeah, Mason. Number 6. Of course, if 6 is not one you need help with, then just go ahead and keep doing what you're doing. Okay, what I would do with question 6 is, this should not need to be U substitution at all, but I would try to rewrite it a little bit first. So we have a constant of 4/3 that we could pull out front and do after the integration. Bless you. And instead of saying the square root of y, we could say y to the 1/2. And then finally, instead of saying y to the 1/2 in the denominator, we could call that y to the negative 1/2 in the numerator. And now we can just undo power rule. Raise the power by 1, divide by the new power. Dividing by half is the same as multiplying by 2. And so in the end, it would be like 8/3 square root of y plus c. Of course, for all 20 questions, I don't expect y'all to do this for all 20, but remember, we're doing the antiderivative. You can always try to take the derivative of your answer to make sure that it works. In fact, on a test, sometimes you can just do that with guess and check if it's multiple choice. You could just take the derivative of all the answers and see which one would give you the correct start. So, okay, is anybody else going to ask about 6? Have something specific before I take something else? Okay, anything else 1 through 9 that you have ready to go? Yeah, Harper.
Number 7.
Number 7? Sure. Bless you. Bless you. So, glancing at number 7, I'm not 100% sure this is going to be U substitution. A lot of times I just really don't know until I start it off. So, if it's U substitution, this is probably your U, since it's stuck under the cube, which would mean this would be negative 4x, and du would be negative 4x dx. So if I tried to rewrite this with u's, this stuff could be called u cubed, but the other parts are x dx. And I don't know what x dx is, I know what negative 4x dx is. But if I'm willing to divide this side by negative 4 and divide this side by negative 4, x dx is equal to negative 1/4 du. Sorry, my 4's and my u's look similar. Okay, and now it's just undoing power rule. Let's raise the power by 1, divide by the new power, plug u back in, attach your plus c, and I guess we could go ahead and multiply these together as well. That's what I would go with as an answer. And again, I know I've been saying check it by taking the derivative, and that sounds like a lot of work, but I'll go ahead and do it here just to show you guys. This would be power rule. If I brought this down, I would get this. I would lower the power by 1, which would give me to the 3rd. And then because of chain rule, I would need to multiply by a negative 4x. And then the derivative of c would be 0. And when I multiply these two things together, negative times a negative becomes a positive. 4 divided by 4 goes to 1. And I am left with an x times 1 minus 2x squared all cubed. which is what we were trying to find the derivative of. So now I'm 100% sure my answer is correct. So I know it sounds like a lot of work to take the derivative to check, but it really shouldn't take too much time. Okay, was anybody going to ask anything else about 7 before I take another question? Okay. I'll leave it up here. Okay, so go another 5 or 10 minutes here, and then I'll bug you for a few more.
split up fractions into multiple fractions. So like, this would be 6 times 2 to the ratio 2 minus 13.
6.
That's only when you're compound fraction. When your number is multiple times by this one. But, I don't think any of these have natural log answers.
Okay, I'll offer to work out anything, maybe the first 15 questions. Anything within the first 15 that would help for me to go over.
Number 14.
Number 14. Let's see. Okay, so for 14, I don't think U substitution is going to help on this one, but we could rewrite this part of it. Three x squared would be 3x times 3x, which would be 9x squared. And then what I would do is I would pull this 1/9 out front. That's just a constant. And then I think we could just get away with rewriting this part. Instead of 1 over x squared, let's call it x to the negative 2. And now we can undo the power rule. We can raise the power by 1. Of course, when you guys are raising something by 1, especially negative numbers, sometimes there's careless mistakes there. And then divide by the new power. So I'll just put the negative over here. And throw on a plus c there. And then these two, I don't know, I would probably move this guy back down to the denominator and end up with that. Okay. Anybody else? Anything about 14? Okay. Another question or two, 1 through 15. Oh, question 15 is almost the same as 14 too. That's nice. Okay, Mason, did you have one?
Can you do 13?
13? Sure. To apologize, my T's and my pluses look the same, so
You have to bear with me there.
I don't see any good U for 13, so I'm going to try to rewrite it first. And by rewrite it in this one, I'm going to split apart my fraction. Just make sure that you never try to split apart a denominator, only a numerator. And then we could rewrite this stuff with exponent rules. These both have a base of t, and when you divide things with the same base, you subtract the exponents. 1 minus a half would be a half. And then do the same thing over here. I'm going to pull the 2 out though. T stuff divided by t stuff, you subtract the exponents. So 2 minus a half would leave 1 1/2. And now that I've split apart the fraction and simplified with exponents, I think the rest of this should just be undoing power rule here. Let's raise the power by 1 and divide by the new power. And then raise the power by 1, divide by the new power. Dividing by 5/2 is the same as multiplying by 2/5. Don't forget your plus c, and I don't know, we can make it look a tiny bit nicer by multiplying these at least. So I would end up with that. So to me, similar to derivatives of last semester, if you just always jump in and try to start off with calculus, there's going to be times you can't do it or you're making it harder. Always try to rewrite it with trig functions or exponent rules or algebra, or in this case fraction rules and exponent rules. Try to rewrite it, because in the end the antiderivative part was not the challenge there. Okay, let's do one more timer here. So I will take any 20 of the 20 questions in the next somewhere 5 to 10 minutes. So go ahead and try to finish that up. If you are finished, I would suggest you check your answers. Worse than missing it is thinking that you got it right and not knowing that you missed it. So you should check your answers on the website. I think that it has some steps included too. I don't think I made those solutions, but I think it has some work shown, so it might help you correct if it was just something small. And then the finish class / homework, I'm asking you to finish up your test review. We did the back page, we did all 3 of the FRQs on the front already, so that should be finished. And we did 1 of the questions on the back yesterday, so you should have like, I don't know, 15 more questions, but I need y'all to do that before next Tuesday. So if you have class time to start it at least, then please move that way. But again, I will take questions on the board one more time after this one more timer's up. one more time. Let me offer anything 1 through 20. Anything from the worksheet I can help with. Okay, well, I did record all the questions my 8A class asked, which was some of the same as y'all's and some different. And I recorded all of the ones y'all asked for, so those will be on the website. So I'm only saying that in case somebody asked a question that you hadn't gotten to yet. You can view that at your leisure between now and next Tuesday. But I put the agenda back up on the board here, so once you have the worksheet finished, I am going to give a few points for the notes from last class, number 90. So if you've not thrown that in Google Classroom yet, you might do that so you don't have to think about it again. And again, I need you to practice the back page of that test review so that you know how I can help when I see you on Tuesday. So I will leave the agenda up the rest of class, but you've got about 15, 16 minutes. Just let me know if y'all find anything that I can help with.